So we're told that there's a flea and it's pushing off from the ground, and while it's pushing off, it's the ground doing work on that flea in order to accelerate it upwards. And we're told what the average upward force on it is. And the first part of the question wants to know what is the flea's speed when it leaves the ground. Well, if we ignore air resistance and the flea's weight, which we're instructed to do, then that means that the net force on the flea is just going to be equal to that upwards pushing force applied by the ground, and so the net work being done on the flea is just that being done by the ground. So ignoring gravity, air resistance, we have that the net work done on the flea is equal to 2.4 times 10 to the minus 4 joules. But by the work kinetic energy theorem, the total work being done on an object is equal to the change in its kinetic energy. And so this we know is equal to a half mv final squared. So the velocity of the object, so a half m times the velocity squared of the object, or sorry, the speed of the object after the work is done on it, minus a half m times the initial speed of the object squared. But this was just 0 because the flea started off from rest. So therefore, we can solve for the final velocity, so the final speed of the flea, by solving this equation here. Now, if we just multiply both sides of the equation by 2, we can get rid of this pesky half. So we get that twice the net work is equal to mvf squared. Now, if we divide both sides by m, we get that vf squared is equal to twice the net work done divided by the mass of the flea. And now to get rid of that square, we can just square root both sides, and we arrive at twice the net work done on the flea divided by the mass of the thing. And we know that mass of the flea is 1.9 times 10 to the minus 4 kilograms. Hence the velocity of the flea as it takes off is going to be approximately equal to 2 times 2.4 times 10 to the minus 4 divided by the mass, which is 1.59 meters per second. Now, part B, it wants us to figure out how far upward does the flea move while it's pushing off. Well, we know what the work being done by the force, the pushing force due to the ground is, and we also know what that force is. So we know then that the work is going to be equal to F pushing force. So this is pushing force of ground. And that work is going to be equal to the magnitude of that force, rather the average of that force, multiplied by the distance that it moves. And so the distance that it moves then is just going to be equal to the work that gets done divided by the magnitude of that average pushing force. And the work that was being done was just this one, 2.4 times 10 to the minus 4. So since we know that the average upward force, so the average upward pushing force was 0.38 newtons then, we can figure out that flea moves through a distance of 6.32 times 10 to the minus 4 meters, or 0.632 millimeters, so not very far at all.